What I want to do in this video is show that matrix multiplication is associative. At least I'll show it for 2 by 2 matrices. And what I do in this video, you could extend it to really any dimension of matrices for which the matrix multiplication is actually defined. So let's look at 3 matrices. So let's say this first matrix is A, B, C, and D. And this second matrix is E, F, G, H. And then finally, this third matrix is I, J, and that's not the imaginary unit I, just the letter I, J, and this isn't E, this is just the letter E, J, K, and L. And I want to look at 2 scenarios. So let me actually just copy and paste this. So copy and paste. So I want to look at the scenario where first I multiply the orange and the yellow matrix, and then I multiply that times the purple matrix. And then another scenario where first I multiply the yellow and the purple and multiply that times the orange. And if these 2 products, based on which ones I do first, come out the same, then I've just shown that at least for 3 2 by 2 matrices, that multiplication of matrix multiplication is associative. We've already seen that it's not commutative, but let's see whether it's associative. And actually, I'll give you the punchline. It is, but let's work through it. And I encourage you to actually pause the video yourself and try to work through it with these letters, and then see if you've got the result that I just said that you should be getting. All right. So let's multiply these first 2. So this product, and I'm going to make it a little bit big. So it's going to be AE plus BG is going to AE plus BG, then AF plus BH, AF plus BH, and then it's going to be CE plus DG, CE plus DG, and then finally it's going to be CF plus DH, CF plus DH, and we're going to multiply it times the matrix I, J, K, and L. And what does this give us? And I'll just give us some space to do this with. So this will give us, I give myself an ample amount of space. So it's going to be this stuff times I. So we could write this as I, and actually let me just distribute the I, A, E plus I, B, G, plus this stuff times K, plus K, A, F, plus K, B, H. I'm already going to run out of space here. So let me clear this. Let me just keep going. And then we're going to multiply this. Essentially, we're going to consider this row and this column, first row, second column. And so you are going to have J, A, E plus J, B, G plus L, A, F, L, A, F plus L, B, H. So these matrices are bigger than I expected they would be. And then you're going to have over here, you're going to have this times this plus this times this. So ICE plus IDG plus KCF plus KDH. And then finally, this times this plus this plus this. Or this times that plus this times that. So JCE plus JDG plus LCF plus LDH. All right. Now let's see if we can power through this one over here. So what is this product going to be? This product, if I multiply these 2 first, is going to be EI plus FK plus EJ, and not EJ, it's not plus, this is the next entry, EJ plus FL, EJ plus FL, EJ times plus FL, then GI plus G, and then we have GI plus HK, GI plus HK, and then finally we have GJ plus HL, and it's all going to be multiplied times A, B, C, D. A, B, C, and D. And I'm going to need some real estate to do this, so let me do it down here. I'll do it in green. So let me do a little arrow to show that this is, actually I could just scroll over a little bit. That actually might work out better. So what am I going to get? So A times this plus B times this. So AEI plus AFK plus BGI plus BHK. And then you're going to have this row and this column. So it's AEJ plus AFL plus BGJ plus BGJ plus BHL plus BHL. Close the brackets. Now you're going to have C times this plus D times this. So CEI plus CFK plus DGI plus DHK. And then finally, home stretch. C times that plus D times this. So CEJ plus CFL plus CFL. And then you're going to have plus DGJ plus DHL. Now, are these two things equivalent? Well, let's look entry by entry. So IAE, this is equivalent to AEI because we know scalar multiplication is commutative. Now IBJ, or IBG, you see it there, and you see it there. KAF, you see it there, and this is the same thing as AFK. And then KBH, this is the same thing as BHK. And you could go entry by entry. Actually, let's just do that. I'll do that really fast. So let's do, so ICE is the same thing as CEI. IDG is the same thing as DGI. KCF is the same thing as CFK. KDH is the same thing as DHK. And go to the second columns. JAE, AEJ. JBG is the same thing as BGJ. LAF is the same thing as AFL. And LBH is the same thing as BHL. And then finally, JCE is the same thing as CEJ. JDG is the same thing as DGJ. LEF, is that or is that LC? So let's see. LDH is this right over here. And so this one must be an LCF is the same thing as CFL. Is this one right over here an LCF? Let me make sure, because that would throw a major monkey wrench into the whole operation. So this entry right over here is going to be, we get that from multiplying the second row times the second column. And we're going to get we get JCE plus JDG. And then we have LCF. Yeah, that's LCF plus LDH. And so you see that these two quantities are the same. It doesn't matter if I multiply the first two first and then multiply by the third, or multiply the second and third and then multiply by the first. Now, once again, this is the associative property. I'm keeping them essentially in the same order. Order matters, but as we see, we can associate these. We can do the first two first, or we can do the second two first.